First of all, I will welcome to all of the participants. I think it's quite a numbers of participants in this afternoon. So the webinar for today, it's on as mentioned by Dr. Nizam previously, is called the KTP Workshop Series number 6 for Industries for 2021. And the title for today will be the STM32 Technology in IoT System Development. So we're focusing on basically in a nutshell, we're focusing the development of an IoT system, but based on STM32 technology. All right. Okay. Apa khabar? All right. My name is Hani Salim. I'm here. I'm not claiming myself an expert, not an expert in this field, in this technology, but I'm a frequent user of STM32. Meaning that I've been involved in microcontroller technology since my early what we call postgraduate educations, meaning that from the earliest years of me doing the tutoring in UTEM, I've involved in all sort of microcontroller technology starting the year 2005, 2006, where the PIC is a boom, was a boom there at that time. And then it goes to Arduino, it goes to another Motorola's, also all sort of microcontroller. Until now, we have a lot of microcontroller that we can discuss towards the development of the IoT system. You can email me, you can contact me for further information with regards to the webinar through my email, sunny@utem.edu.my. Okay. So for today, it will be a brief 1 hour webinar. So I would like to address 5 points to be explained. First of all, is at a glance of the microcontroller scene. We're talking about microcontroller because STM32 itself is a microcontroller, microprocessor devices. So we talk about the microcontroller first, and then we go to the IoT scenes. So the second one will be the comparisons of popular microcontroller boards. Popular meaning this you frequently use in Malaysia, with regards to Malaysia market, with regards to the exposure to the students, right? That what the students are currently in experience towards their curriculums, towards their studies, and towards the hobbyist community, which is prevalent in Malaysian's environment, not Europe, not US, not other parts of the world. We were focusing on local content. And then when we go to the STM32 portfolios, the whole catalog on what are being offered for STM32 microcontrollers and microprocessor. We're looking to the discovery board, we're looking to the Nucleo boards, and what are the functions or the features that the board can offer towards the development of the IoT platforms. And then we go a bit on the Internet of Things, the structure, the architecture, the technology that involved to develop a simple IoT, and finally a practical approach, meaning what we've been doing here at UTEM at STIoT Lab, and then what are the tools involved, what are the sensors involved, and what are the platform that will be required to develop a simple but full-fledged IoT system. I hope that these 5 topics will complement the title that we're just suggesting today. Okay, all right. So without further ado, I just come across to the first title, which is the World of Microcontrollers. It is a big world. It is a big world. So we have a lot of microcontrollers manufacturers. Okay, it's not just ST Microelectronic itself. We got the Atmel, we got the Expressive, we got the Freescales, Texas. All are companies that are manufacturing the microcontroller themselves. Okay, so these type of manufacturers produce tons of microcontrollers that have their own capabilities, their own feature set, then their own types of applications that is not just one size fit all. You have to tailor made or you have to customize your application to suit the microcontroller or the other way around. You customize the microcontroller to suit your application. So that will be discussed for today. But for today, we're discussing directly on the STM32. But then again, it's not just STM32, it's not just Arduino, it's a lot of microcontrollers out there. Okay. And for the popular microcontrollers award, this is I'll gather this information from our U10 students, meaning that the projects that have been being done, and then the implementation towards the curriculum assignments and all the subjects that related to microcontrollers, microprocessors, and we come up with five what we call more well-known microcontrollers, which is among others are being adopted by usually frequently adopted by the students. First of all is the prevalent the ubiquitous Arduino, and then we're gonna take a look a bit on Cduino shell, which is another type of controller, and then we got a 10C, 10C, something like that. And then you got Raspberry Pi Pico, the new kids on the block for the microcontroller scene. And then special mention on the Node MCU, which is the ESP32. And finally, the number 6, we go to the STM32, and then we're gonna compare and how well the STM32 compare to each other, and what are the differences, what are the advantages and the disadvantages of these microcontrollers. Okay, first of all, the undisputed, the most famous, the what we call the de facto of the microcontroller is Arduino. It's either Uno or Nano or Lino. They have a lot of variation from the Arduino boards. So originally the board is controlled by a chip called Atmega. We got the ubiquitous Arduino board. Everybody loves this board. It's very easy. It's very simple. It's very well received by a whole lot of community. And because it's very famous, the pin out of the Arduino is already adopted through other types of microcontroller board as well, including STM32s. So because the ecosystem has been well developed and well received by a whole lot of communities, so it will be what we call the most recognizable microcontroller board for the current being. Having said that, there are certain limitation of Arduino, meaning that the abstraction layer, or what we call the code themselves, is very simplified, that for a first-time user, it will be easy to adopt the codes, easy to adopt to the system, easy to build the system from scratch. However, for more advanced user, and I assume for more industrial applications, Arduino or Arduino Uno for this kind of board, it's not really what we call suitable. It can produce, or it can develop the certain applications, but if more power need to be needed, more low power application need to be addressed, or more specific performance need to be eked out from the microcontroller, then Arduino Uno has some sort of limitation in terms of performance, in terms of clock frequencies and other types of features that will be covered or will be complemented by other types of microcontroller. So for students, for newcomers, for beginners, Arduino is a very good starting point. But then again, if you went further for industrial application and so on, Arduino is more like the prototyping stages. But when implementation stage, when the project goes to implementation stage, they will develop either their custom board or they will move on to more robust and uh, more robust and reliable board other than Arduino. Moving on, the second part will be the second board that listed on the most popular microcontrollers is we will call it Arduino Xiao. It's a very tiny board. It's a very tiny board. It's just like 8 pins, not 8 pins, like 12 pins in total. Very tiny, a little one. It's using the ARM Cortex M0. ARM Cortex, I will relate to this later. Memory is 32 kilobytes, 256 kilobytes for ROM for memory space, 48 megahertz of clock with a price of 35 ringgit. So this is very tiny, which is suitable for what we call applications that very sensitive on the size and on the constraints on the limitation of size and space. But again, the tiny board meanings very few IOs, meaning that you are limited towards your input-output devices, input-output sensors, but it's very tiny and it's using USB-C. So maybe suited for certain types of application that require very small footprint. On the other hand, we got Tinsy. Tinsy, it's using Cortex M7. We got 1 megabytes of RAM, 2 megabytes of ROM, 600 megahertz of clock. This is, I think, I think it's the lowest or one of the highest rated frequencies on the microcontroller board. So the prices is quite high, which is like 80 to 130 ringgit. So this is more towards performance-based applications. You need higher clock speed, you need higher memory bandwidth, so you need higher space of ROM. So Tinsy will be the much suitable microcontrollers within that certain spec of applications. Again, with a higher performance came a higher cost. But if your project required to do to have that sort of performance in terms of clock frequencies, and then Tinsy is a must-have. You don't have other choice than that. This is a new kit, not a block. I call it a new kit because it's recently launched, like last year, I think. It's Raspberry Pi Pico. It's using ARM Cortex M0 Plus. We got 264 kilobytes, 2 megabytes of ROM. It have a clock frequency of 48 up to 133 megahertz, and it's $18 to $20, 20 ringgit range. So it's a very compatible. It's a very what we call commendable board because of course it's supported by Raspberry Pi, meaning that the software application is more diverse, meaning that you can adopt using C++ as your main program, or you can adopt to using Python or MicroPython for that matter. And then because it's supported by Raspberry Pi, the ecosystem could be large, meaning that it will expand to the Raspberry Pi communities, and they have their own software development team. So it will be what we call the board, the Pico board. It will be good to acknowledge or to focus how the progress of the board development in terms of peripherals, in terms of accessories related to the board itself. So this is a newcomer to the market. And mentioned on this is not MCU ASP32. This is what we call the famous board for integrating with Wi-Fi and Bluetooth. So the chip itself, the microcontroller itself, compared to other types of microcontroller board, it's about microcontroller IC and then separate communication IC such as Bluetooth BLE, Bluetooth Low Energy, or the Wi-Fi chip, which is separately, or which is what we call heterogeneously. But for non MCU SP32, it's integrated, meaning that on the same die, we have the MCU itself, the microcontroller itself, dual core right now for the ESP room. And then we have integrated with BLE and also the Wi-Fi chip. So it possesses 130 kilobytes, 4 megabytes of ROM, 14 megahertz, and it's very cheap for $15 and $30, 30 ringgit, meaning that you got the microprocessors together with the Wi-Fi chip. So for most applications that require Wi-Fi or Bluetooth, this is normally they will go first, unless they want to have some sort of other types of functions uh, as a complement to the Wi-Fi communications. That will be they will be opting for another types of port. Having said that, having said that, this is not the only board that can be connected to Wi-Fi. All of these previous board that I mentioned, Arduino, Teensy, even for the Arduino Zhao, can be connected to Wi-Fi themselves. But Wi-Fi themselves. But then again, they have to have what we call the expansion board, the additional daughter board. That will be the case for all other boards, except some sort of development board that are integrated within the same board, the IC, the Wi-Fi IC, the Bluetooth IC, together with the chip themselves. We'll explain it later, especially during the STM32 portfolios. And finally, we go for the STM32. This is what we have. This is one of the options for the STM32. We call it a Nucleo F401RE. This is what we have, what we already being adopted inside curriculum for FKEKK or in UTEM. So F401RE is not the famous one. The famous one is 446, I think. But it's within the same families. We got Cortex M4, 130 kilobyte, 512 kilobytes of ROM, 100 megahertz of clock frequencies, and then it costs about around 65 ringgit. And okay, to put inside a table, so we can see that there are a trend of price per performance comparison, performance rating, meaning that if you want a higher performance, you have to have the Teensy, which is regarding ARM Cortex M7 controllers with the highest rated 600 megahertz clock frequencies. But then again, it costs you like around 100 to 130 ringgit. Okay, and you can go for cheap, which is the Pipico, for example, or you can go for Arduino Uno, for example. You got 30 ringgit, 20, 30 ringgit Arduino board. The 100 ringgit Arduino board I would like to mention is the original Arduino from Italy. The Arduino PCBs, all of the are manufactured by the original Italian company. The one you have that 20 ringgit, 30 ringgit, 40 ringgit, either is a variation or we call it clone, but it's still compatible with the programming and also and all others software development tools. Okay, so in the end, if you look at the Nucleo part or the STM32 part, it's more like a middle ground. So you have the M4 processors, MO microcontrollers, which is good enough, and then we have the clock frequency, which is 100 megahertz, which is not too high and not too low, which is good. And then we got the price itself is like 65 ringgit. We got 55 ringgit if you got an offer. So that will be what we call the middle ground. Middle ground meaning that the device, the board is capable to perform very simple things, very simple I/O transfer, very simple I/O management, and then the device itself also capable towards more computational intensive program, called computational intensive programming, such as data transfer, signal processing, and then a bit of filtering and data aggregation. So it can perform within the board itself. So that will be the what we call the main point or the advantages of having the STM32 other compared to other itself. But that's not the only point. I will discuss this later. Okay. All right. So actually, what are the portfolios? What are the boards that are being offered by STM32 themselves, by ST Microelectronics themselves? So we will cover it in terms of hardware and also software. So this is the general purpose microcontrollers ranking. So ST right now it's based on the data. ST is ranked second in general purpose microcontrollers, uh, just behind the microchip. So this is dated at last year's data. Okay, so ST microcontroller boards is divided to what we call few families. Okay, so we have the one is a nucleo board, which is a flexible prototype. Okay, and then the nucleo boards, the left side is good for prototyping. It has a debugger themselves. It's for testing the code products and then uh, develop towards the final variation of the applications. And then we go for the higher version, which is this discovery kits. This is more integrated, more what we call more features are integrated within the same board. It's including the communications protocol, including the sensors, including the I/O peripherals. These are all integrated in the discovery kits, which is the higher tier from the nucleo boards. And the highest one will be the evaluation boards. This is more towards very industrial, compact, and then integrated board, which has all sort of bells and whistles of the application themselves. So you can have the LCDs, we have the displays, we have the display port communications, we have the IOs are very um, multiple choice of IOs are being available on the board. So that will be the evaluation board, which is the highest tiers of the STM32 portfolios. And the other one will be the STM32 nuclear expansion boards. This is in related to the first nuclear development board. This is more like the add-on daughter cards for the nuclear development boards, meaning that the nuclear development boards is only consists of what we call simple LEDs button, and then the expansion port, and together with the MCU, the ARM Cortex M4. But if you want to add on certain functionalities such as motor controller, for example, MEMS sensor meaning the environmental sensors such as magnetometer, gyroscope, that you can adopt or you can integrate with the nuclear board using the nuclear expansion boards. So it's just like an on-stackable boards that are compatible with the Arduino pin layouts. Okay, and I have to mention that with the Arduino shields that are very popular because of the Arduino Arduino pin out that is also being popular. STM32 Nucleo boards also have what we call the Arduino pin out, meaning that all the Arduino shields that have been created, although it's been created originally for the Arduino boards, can be compatible and can be inserted to the Nucleo board themselves. So meaning that it's compatible. The board can be used as the functions can be used by the STM32 boards, but provided they have the libraries. They have the libraries. So meaning the sensors library, for example, is being adopted, is being also allocated with the STM32 development tools. Finally, the third-party boards, it's custom-made boards. It's can be designed, but based on the same ARM chips, and then it's for certain purpose, that for specific functions. So normally inside the education scenes or inside our education curriculum, we'll be more focusing on the nuclear boards. However, the architecture or the development tools also can be applied towards discovery kits and so evaluation boards. So this is a matter of progressing from the lower tier towards the higher tier. So all the systems are, all the development tools are the same, all the, what we call, the software development process also, the flows also remain the same. So this is an example of what we've been doing for our curriculum. So this board is for the F411RE. So on the top half of it, it is a debugger. It is a debugger, meaning that we're using the ST-Link version 2, 2.1, version 2. So debugger meaning the students or the user has the capacity to debug the codes using the built-in debugger. Debugging meaning that you can trace line by line all the codings to either you detect the other errors or troubleshoots all the source codes, and then rectify or if there any error or any malfunctionality on the codes. Okay, so it's a very simple board, meaning that you have the IC, the direct in the middle will be the ARM Cortex M4, and then you got two reset buttons. You use one reset, the black one is reset buttons, and the blue one will be the user button, and also the connectivity, which is the Arduino pin layout, and also the Morpho pin connectors as well. So it can be powered by USB port, so meaning 5 volt 2 amps, and then it also can be powered using a power bank. Once you program the board, and then you just put in a power bank, it will run as usual. Okay, this is a variation of the what we call X Nucleo, meaning the expansion board for the Nucleo development board. So we have X signage on the, after the X Nucleo something. We have a whole lot of types of expansion boards, including sensors, communication. We got Bluetooth, power line communication, also for motor drive, meaning we have the stepper motor, all the drivers and the relays are all integrated, meaning that ST will provide the library by themselves and it's compatible towards the development of the application for the Nucleo board, and also any other boards that are compatible with the Arduino pins. Okay. For the software part, there will be the hardware part. We're done with the hardware part. And for software part, this is more like the ecosystem suggested by STM32, by ST themselves. So we got the STM32 software development tools. So we have three modules, but all of these can be integrated, already been integrated into one software we call the STM32 Cube IDE. So the first part will be the configuring, generating the code using the STM32 Cube MX. And then we're moving for compile and debug the IDEs using the STM32 Cube IDE. This is where the variations comes in. Meaning that you can use the ARM embed, you can use the Kill, for example. Even you can use Arduino. There's a logo Arduino over there. So you can use Arduino to program the STM32 themselves. It's not just STM32 for STM32, Arduino for Arduino. It's not the case. So if you have the Arduino itself, it's more open towards other types of architecture, as long as they have like board managers or have library being compiled. So you can use Arduino to compile STM32 boards. It's okay. And then finally, to monitor and program the boards and for other types of utilities, they will be using this STM32 Cube programmer, monitoring for the STM32 Cube monitor, meaning you're monitoring the in-outs of the data, the registers watch, the memory allocation watch, and then data being sorted out, something like that. Okay. So this is the what being suggested by STM32 or ST Microelectronics. It is being applied to its curriculum. Alternative would be on the IDE side, on the development tool side. So apart from the STM32 Cube IDE, users can also use Arduino IDE, but with less supported board, meaning that if you have a prior experience or prior knowledge in programming an Arduino board, Most likely, if you're in the microcontroller field, that will be the first thing that you can learn. So there are what we call ways, or there are method to program the same codes, or not the similar codes, but instead of you program to the Arduino board, you can program the codes towards the STM32 board. So in this case, you can apply the codes with minor corrections, with minor modifications from your Arduino codes towards the STM32 boards. There's one option that we can explore. And finally, we have the famous one will be the embed. Embed, we got 41 boards supported. We have 35 expansion board. This is more online compilers that embed is famous for. And then embed also have what we call the already launched. It's also what we call the embed studio. Embed studio within the full-fledged IDE, again using their own hardware abstraction language, HAL, and then they have the capabilities to program the STM32 board. So you got the same STM32 boards, but you have options, alternative, either to program it using the STM32 Cube IDE, which is very full-fledged, very full-fledged IDE, well supported, tons of libraries. And then either you go for Arduino IDE, meaning that you can use your prior knowledge or previous experience using Arduino and then modify a bit to applicable to be programmed for the Arduino boards, or you can use the embed, which is an online compiler experience using C++ code programming, has their own libraries, and then it can also be programmed towards the embed STM32 board. So you have options, and it's very well diverse. Everything got its own positive and negative pros and cons. And then it's not just one size fits all again. So for today, we will discuss later on what are the practical approach that being applied in our curriculum, in my experience of doing the STM32 development. Okay. All right, moving on to the IoT. IoT is it's basically a buzzword for how many years? It's been here, and then I think everybody knows right now what is IoT. But the thing about IoT is it's not just about the device that is connected to the internet. Okay, it's not just about your device connected to the internet. You can call it IoT. It's part of the IoT. It's halfway towards the IoT. But the IoT itself, it's towards more about creating new knowledge based on data being transferred or data being collected and data being analyzed. Okay, if your device is just about matter of collecting data, meaning transferring data, turn on, turn off, turn on, turn off, but you don't learn, or you don't have some sort of data analytics, and you don't have some sort of new information coming from those data, so it's not IoT per se. Okay, so this is what we call the IoT enabling technologies. So first of all, you have to have the sensor and actuators, of course, to collect the data, and then to sense, and then to actuators to respond if the system applied. And then you have to have the communications, meaning that you have either a choice of RFID, short term and short range and long range, meaning that you get RFID for shorter range, Bluetooth, Bluetooth for short range as well, Wi-Fi for medium range, and LoRa for a longer range. So you must have what we call the communication medium, that connects the sensors, the nodes, what we call the IT nodes, towards the resources and the database. And then the protocols, of course, we need to have a protocol as well to communicate between the sensors and also the database. So we have the communication protocol, which is the communication medium, which is what we call the highway. And then the protocols within the cars, or what types of transfer that we're dealing with. What are the protocols that we're dealing with between the sensor node and also the sensor node and also the database or these cloud resources. So the protocols can be HTTP, can be WebSocket, and can be MQTT. And finally, for data analytics, you can use all these big companies such as IBM Watson's, AWS for Amazon Web Services, Azure for Microsoft, ThinkSpeak, you name it, Blink, and uh, Link, Things Work, and then we got Favorites and so on. These are the platform, we call it IoT platforms. That what this platform do, it's consolidate the data, segregate the data, aggregate the data, and then consolidate and then do some sort of analytics. That in the end will produce new information. That will be the what we call the back end of the IoT. Normally for layman, for normal user, it's like when connected to internet, it's just IoT. It's half IoT, I would say. So when you do some sort of analytics, and then and then come up with a new information, that will be a full-fledged IoT system development. I'll give you an example. If you have an air conditioner, right, air conditioner, and then the air conditioner connected to your apps on your phone, on your smartphones, and you can control the temperature. Good. Does it call an IoT system? Not really, because it just connected to the internet. You have to have the control to control the temperatures and so on and so on. Okay, but when the air conditioner become IoT is when they have a whole lot of data, meaning that periods of 1 month of data, that okay, know when the temperature is high, when the temperature is low, and then how many hours the aircon is turned on, how many hours the aircon is turned off. And by that data, it will come to new information that okay, this is you are required to service the aircon, for example. The certain limits of hours have been passed, and then you have a new the system determine that okay, the aircon need to be services by this time, this time, that time. So the new knowledge come, the time of service the aircon. The new knowledge come from the data, and the data is collected using your smartphone and so on and so on. That will be the whole IoT system. Okay, that would be some simple examples that I can think of. Okay. For my studies, there are certain types of level what I can say for the IoTs. They are proposed by other researchers that IoT got some sort of not some sort. They got 5 level of IoTs. So level 1, if I can mention here very quickly, is a single node device that performs sensing actuation, store data, perform analysis, and host the application within the local environment, within the local network. The big box over there is local, meaning that it's not integrating into cloud. There's no internet. There's just only network, current local network, meaning that it can host all those services, all those applications, all your apps, all the devices, data transfer within the own network. If we call the IoT level 1. For level 2, on the other hand, is still using a single node device that performs sensing actuation and local analysis. The data is stored in the cloud, and the application is usually cloud-based, meaning that right now, the database and the services are transferred to cloud. This is where the internet connection comes in. But the device and the resources, the controllers, which we call the IoT nodes, is for the is maintained on the local network. So you have to have an internet connection. Of course, the name is Internet of Things, and then all the processing part, all the data transfer part, or the database part will be done inside the cloud. So we got a level 3, 4, and 5, but I won't dwell too much on it. It goes to very technical, on the technical side of it. Okay, right. So practical approach, meaning here it's what we've been done at UTM, especially STIoT lab, and also what are the projects that are being involved previously in terms of how we implement the IoT development system development utilizing the STM32 hardware. So this is one of the local setup. The main highlight will be, this is for IoT level 1, as I mentioned previously. We got no internet connection, meaning that all are within the local network. We start with the nodes. We got on the left side, we got the sensors, temperatures, humidity, any types of sensors. And then it's incorporated to the IoT nodes, which is the STM32 nuclear boards. We have several boards of it. And then the tiny chips next to the STM32 is what we call the ESP8266. This is the Wi-Fi, what we call a Wi-Fi modules or Wi-Fi adapter. This chip that makes that enable the nuclear F411RE to be connected to the internet. By F11RE itself, the board itself doesn't have any Wi-Fi IC integrated. So we're using the external chip or external module called the ESP8266, very cheap, like 14 ringgit per IC. And then it's enabled within the protocol, enabled to be connected to the Wi-Fi, which is supplied by the router. And for the server and database itself, we're using the Raspberry Pi over here. And then the elephant icon will be the PostgreSQL, which is the database. So the database, the Wi-Fi are located inside the Raspberry Pi server. And then all the applications, all the dashboard, all the display information can be monitored using your smartphone and tablet using the apps. And the whole system are relying on what we call the Blink local server. This is Blink is part of the IoT platform. Okay, it's very famous IoT platform, and also have what we call the algorithm to perform our own local server. So we have the app, Blink apps is very well established. So we have the smartphone apps to be there. And then for the dashboard, we're using the Grafana connected directly to the HDMI of the server. This is all towards IoT level without the internet connection. So this is sometimes some sort of organization or some sort of company, maybe like we have a small sensors or small workspace of sensors that want to be connected, but we don't want to interfere with the backbone of IT infrastructure back on the company. So this is one of the options. And then it's very, what we call, it's very body isolated, meaning isolated. So it's within the connection within the router itself. Okay. So the issues of securities will be controlled within the router, within the network, without interfering to the public domain, something like that. But however, Blink, the company, Blink IoT, already migrated towards the new version of Blink 2.0. So the Blink local server, I think is just recently updated. So for the past 2 months, I think the Blink local server it's not being updated towards the newer version. So we look into that. So whether we can prolong the use of Blink local server, or we just gonna maintain the old version to have this setup being run. So the setup is being organized by, is being allocated inside the ST IoT lab for better, what we call latency, better communications between the IoT nodes, also from the server and directly to the smartphones. Okay, because it's local. It doesn't involve any IP domain or external access for the internet. Okay, the other part will be the one that I'm gonna have to demonstration for today is the IoT level 2, which is the development setup, which include database and services, which is located in the cloud. So first of all, we got the nodes starting from the left. So we got the nodes. We got the again nuclear F401RE with the expansion module, which is the ESP8266 Wi-Fi. And then the other ports that will be utilized in this example will be the B75E, 475E, IoT01A, which is the IoT nodes discovery kit from STM32 for ST. This is STM32 discovery kit for IoT. So the good thing about the IoT01A is the Wi-Fi chip is integrated inside the board. So on board integrated Wi-Fi chip. And furthermore, as it is called a discovery kit, they have also built in environmental sensors such as temperature sensors are built in, humidity sensors are built in, gyroscope sensors, and also the magnetometer. Yes, it's built in as well. Of course, it will include other capabilities such as SD cards and then few also compatible with PMUD connectors and also the Arduino's connector as well. So it's a very what we call compact board, got built-in Wi-Fi, which is very good for IoT development. But it costs you around 265 ringgit, something like that. Yes, 265. Yeah, compared to Nucleo board on Nucleo F411RE with plus ESP8266, it costs you like 80 or 90 ringgit total for both boards and the ESP8266. The discovery boards, it's integrated, full featured, and it costs you a bit at 265 ringgit. But it's worth it to my what we call to my experience from the students as well. Because as the Wi-Fi is integrated with the boards, all the communication are more stable, all the communications are more robust, so you can rely on the data transfer and so on, compared to the expansion board, compared to the expansion Wi-Fi adapters that being utilized by the F401RE. There are some sort of instabilities. There you need to do some sort of reprogramming one time to another from time to time, and then just to make the bots work. So they are trade-off. Yeah, but again, based on requirement and based on the application budget. For the framework, so we're using what we call the STM32 Duino right now, the blue color. The logo, Infinity logo, is come from the Arduino themselves, but we have an STM32. We call it's an amalgamation between STM32 and also Duino IDE. So we call it STM32 Duino. This is the framework that I mentioned that for the prior user or previous user of Arduino IDE or Arduino code can utilize the same code with minor modification and then apply towards the STM32 board. Okay, so this is what we call the best of both worlds, meaning that you can have the Arduino code, a simple, very straightforward Arduino codes, but you can apply it to the STM32. The downside is you can't explore much on you can't unlock the capability of the STM32 using Arduino codes. You have to use the HAL, STM32 HAL framework to unlock all the capabilities of the STM32 codes. But for a simple beginners program, for whoever that wants to embark on STM32 hardware or STM32 boards, STM32 is a good start. Again, it's a good start, especially if you have a prior experience from the Arduino himself. For the IDE, this is more like a personal preference. So we're using the VS Code, the very famous code editor, Visual Studio Code from Microsoft, together with the expansion of Platform IO. So the advantage of Visual Studio Code is a very full-fledged and very rich features code editors. So you can have all the colors of the themes, all the code auto completions, all the error corrections, and this is being offered by VS Code compared to very basic Arduino IDE and compared to very complicated STM32 IDE Cube, Cube IDE, all right? So VS Code is very well maintained and very well feature rich for code editors. And to enable it to program the STM32 or any other microcontroller boards, we have we have need to install the extension called the platform IO. So I will show this later. And then for the communication protocols, okay, we're using Wi-Fi because we're using STM32. We're using Wi-Fi for the communication mediums. The protocol using the REST API over HTTP. This is for the one that know the HTTP protocol. We just put the post request and get request and just post get and receive delete request whenever it's applicable. So we use that SPE. And the platform here we're using ThinkSpeak for the reason that ThinkSpeak is supported by MATLAB because they have what we call the functions of the MATLAB, what we call functionality. You can do a lot of data analytics to MATLABs. Taveriet is our local IoT platform led by Dr. Mazlan Abbas, our industrial advisory panel. So Taveriet is another option that we can delve to. All right. Okay. A bit of demonstration. Boleh Dr. Nizam? Sekejap. Empat.
InsyaAllah boleh.
Okay, sekejap ya. Saya.
Okay, in the meantime, kalau sesiapa ni boleh fill up the attendance and feedback form. I already put it inside the chat.
Okay, start from basic. Okay, this is the first piece of the Visual Studio Code. All right. Okay. So for the first and then you have to make it enable to program the STM32, you need to install what we call the platform IO over here. Okay, platform IO. This is the extension that enable not just you to program the STM32, but you can program all other types of microcontrollers. For example, here I just click on new project. Let's say for test, for example. And then we have 132 boards over here. If you put the IoT (01A), for example, the discovery kit. So we got F401RE, and then we got the, let's say, Uno, Arduino Uno, we got Teensy, all types of version of Teensy. Then all can be programmed using the VS Code together with the platform IO. Okay, so this is one of the advantage, meaning that if you want to program Uno, you can use VS Code and platform IO. Let's say you want to code STM32 Nucleo F401RE, you can use it the same interface, same IDE. And then if you want to use something like other types of microcontrollers, you can use the ones that are supported by the platform IE. All right. Okay. So I just go directly to the examples. So I just open folder. First of all, I would like to connect the F401RE towards the ThinkSpeak. So, okay, this is the code. Basically, what the code's been doing here is, okay, so it will establish the Wi-Fi connection first here using the software serial for STM32. This is specifically being compiled for F411RE. And then we set up the serial interfaces. We can serial interface with soft serial This one is just sending a random data, set up this serial baud rate, and then connect to the Wi-Fi over here. Connect to the Wi-Fi, and then set up the ThinkSpeak using the thingspeak.h library. Okay, okay, all right. So the good thing about the VS Code and the VS Code and the Platform IO is all the programmers, the buildings, the build and the uploading tasks are provided together with within the IDEs. And then all the settings, which is with regards to the library over here, it's all can be configured using the platform initialize. So here it will maintain that it will stated that the project or the board will be the Nucleo F41RE. Framework is Arduino. Again, it's the name Arduino, but as it applied to the Nucleo F41RE, which is STM32. So we're gonna have it as the STM32 Duino. And we got add another library, which is the MathWorks for ThinkSpeak library. So let's say if you want to add another library over here, so the one that we'll be seeing here is the Wi-Fi ESP. So it's just a matter of searching the library inside the IO, inside the platform IO. So Wi-Fi ESP here. And then we just copy the you can add to project, but my preference will be just copy and paste towards the platform IO ini. All right. And then save. So that's it. So what happened when you compile all the codes, the VS Code will automatically download all the libraries required, and then it will generate the binary files that will be programmed towards the STM32 boards. So we compile. So here it will populate all the libraries that needed. And then at the same time, you can visit the ThinkSpeak website. So this is the prior data that been loaded from the sensor being collected. So once the item being collected by being processed and is accessed and processed from the board, being programmed to the board. So all the data, which is the random number over here, will be logged by ThinkSpeak channels. So you have, this is a free accounts of channels. So we had most like at most six or eight fields. Okay. But, and then all the data will be logged out, will be logged into the, within the database. The good things about ThinkSpeak is you can have what we call the MATLAB analysis and MATLAB visualizations, meaning that once the data is populated, when you all have gathered all the data, so you can perform some sort of MATLAB functions. For example, here to perform data analytics. That's a good thing about it. The bad thing about MATLAB, the ThinkSpeak, especially on the free account, is the data can only be transferred within 20 seconds period, meaning that the data can be accepted by the server, TeamSpeak server, within 1 second and 20 seconds. If you get data in between, the server will just ignore it. Okay, so you have some sort of like 20 seconds of delay between the first data and the second data. And also again, the bot, meaning the data can be acquired by multiple devices, meaning that the first one will be F401RE, and the second one will be the IoT 01A bot. So that will be those device can produce or collect the data, and the data stored inside the TeamSpeak database over here. Okay, so that the main thing about the TeamSpeak. The other platform will be the IoT platform, favorite IoT platform. Okay, so again, same components, what we call same types of data connections, meaning all the data will be populated and will be stored inside the F401RE over here on the IoT platform. And then the data can be exported as well, data streams. Okay, for example, here I'm sending the humidity and temperature sensors from the first IoT 02A, 01A, okay, and the data can be exported. And also for the IoT platform as well, favorite as well, we have what we call extension towards Node-RED and towards Telegram for notifications. So it's a matter of how you want to consolidate, how you want to analyze the data after it's being logged or after it being stored by the respective IoT platform. In this case, which is the IoT favorite IoT platforms. The other one will be the TeamSpeak platforms. Okay, this is a free account, meaning that they have self limitations. The one that I've been mentioned before, 20 seconds limitation for the TeamSpeak. For the IoT platform, the favorite platforms, your data it's kept for, this is beginner accounts, kept within like 1,000, 5,000. This is for the beginner account. For free account, it's like 500, something like that. So it can, only 500 times data can be submitted to the server, can be logged to the server within the same day. So if you have more than that, you have to wait for next 24 hours, and then you have to resend the data. In case of code architecture, this one for F411RE, the other one will be the ST. Just show you the last one for the IoT. Okay. So basically the codes are similar towards to the Arduino. Okay. So we got the includes and all the classification. These are all the codes, especially for IoT 0A, it's being provided by ST themselves. Okay, so you can just copy paste the code and then insert the element. This is what I mentioned by the HTTP post request, which is the REST API. So by configuring this program, this instruction, we're sending the data from the board towards the in this case with favorite platforms. Okay, and so the data, of course, the data will be logged, and also the code by the features of the VS Code. The code also can be shared or can be source control using GitHub. So all of this code, as per our what we call code programming development. So we have all these logged into our GitHub repository, which is under the name of team-iot-fkekk. Tunjuk tak? Here, so we got this team IoT FKKK. All the list of the codes are situated, are located here. So all the code are shared, and then it can be usable depending on the platforms, depending on the board itself. Okay, because of the flexibility of the board, so all the Arduino libraries, all the sensors or actuators that already have Arduino libraries can be compatible and be available to be used inside the code as well. So that will be a big advantage by using this combo VS Code plus platform IoT. And then of course we have all the code completion and so on. All right. So that will be the case about the approach that we've been delivered. From the get-go, the sensors, either integrated or external sensors, and then compile it using code, using the VS Code and Platform IO. For the time being, I'm showing the STM32 Duino framework, meaning that Arduino compatible coding that are applicable, programmable to the STM32. And then all the data collected from the sensors, from the board nodes will be transmitted to the IoT platform. It's either by using ThingSpeak or Favorite. And then it's not just it's not just ending about from the data collection phase. You can generate more from using the data analysis from the MATLAB, or you can create notifications or node-REDs or something further data analytics from the Favorite IoT platform. So this is two most widely used platform for our curriculum, for our students. And then we also have other types of platform like ThingsWorld and Cayenne, for example. But then again, this is more user-friendly and more feasible to our curriculum. Okay, all right. So towards the end of my presentation right now, so finally a bit on ST-IoT Lab. This is our main playground in FKKK in UTEM. So it's established since 2018, 2019. So it's fully supported by ST Microelectronics MOA. Thank you very much for the support. And then we are focusing on STM32. We also catered other technologies, Arduino, we got Raspberry Pi, we got Motorola's PIC, even microchip PICs. And we're training on best practices, meaning that the one that are applicable, the one that are applicable to the local environment, okay, local scenes that they want to cater off. This is what we're being planned for the ST IoT Lab. So we already have the ST Nucleo F401RE, which diverse into various sub fields, such as the primary school, secondary school, real-time OS. We're using the ARM Embed framework, microcontrollers, control system. We are utilizing MATLAB. Internet of Things, we are using Blink, ThingSpeak, and Favorite. And we are also applying STM32 Cube IDE again to unlock the features of the STM32. You need to use the Cube IDE, such as low power, machine learning, so on. And we also delve into machine learning, which is a sensor tile, which is under current development. So this is the plan for ST IoT Lab. We are open for any cooperation, any consultation with regards to the program. But again, I believe that there is no one size fit all for the microcontroller technology world. So then again, it's about how do you cater, how do you minimize and maximize all the potentials that you want to have in order to develop very efficient and very good IoT platforms. I think that's about it, Dr. Azim, for today. Okay. For any questions, yeah, feel free to ask, and then you can also reach me at sunny@utem.edu.my. Thank you.
Hello, Assalamualaikum, Dr. Nizamuddin and Dr. Sani.
Waalaikumsalam.
I'm Muhammad Fakih Mohsin from ST Microelectronics. I'm a test engineer. I would like to ask: is there in UTEM any postgraduate courses that focus on the production or manufacturing of the semiconductor, such as quality control or something durability of the microchips? because I understand you present most of the thing is the application of the STM32, how to make an application, but do you have something like in term of productions or manufacturing of the semiconductor?
Okay.
Okay.
Correct. Thank you, Fakih, for the questions. To my knowledge, within our faculty, the Faculty of Electronic Computer Engineering, FKEKK, for postgraduate level, we don't have specific on manufacturing sides of the IC manufacturing side. We have what we call a course that runs to it, but it's more like a course within a bigger program, meaning that we offer the microelectronics master of electronic engineering, but there are one course of that within the we name it embedded system design, for example. So that will touch a bit on the manufacturing side, about the IC production side, but it's not full-fledged. It's just mere topics or one course within with the whole 30-40 credits. I do think I'm not sure about FTKE FTK no about FKP, our manufacturing faculty. So
Okay.
maybe we can look into that. But on our part of our faculty, we just have the one course part from the program.
Another question. I understand that you use the MATLAB to analyze the data that come from the STM32. But is there any possibility that the MATLAB can configure the process of the microcontroller?
Yeah, there is. MATLAB has some sort of the function called the embed coder design that are compatible to the STM32 boards. The ones that I've shown here, F401RE, IoT 01A is compatible with MATLAB, meaning that you can use the Simulink module platform. You have the block diagrams, all the stuff, and then you have reconfigure the codes and then reprogram back to the bots. So you can reconfigure or reprogram the bot using Simulink through MATLAB. But you need to have those libraries lah, the toolbox of the embedded coder, and then the support packages for the STM32. It's doable.
All right. Clear. Thank you.
Right.
Assalamualaikum, Cik Sani.
Salam.
Assalamualaikum.
Okay, I'm Shuko from finishing department ST Micro.
Okay. Cik
Okay.
Syukur, yeah.
Okay. Actually, last year I did have one intern from UTM.
Okay.
And, we worked together on some quite a bit small project on IoT. Yeah. But I found that the student itself, they have a very so-called not well vast knowledge on STM32 programming, and they are more on Arduino.
Okay, yeah.
Okay, and whereas our intention over here, we try to utilize as max as possible on the STM32 application, lah.
Yes.
So is it possible? Because and then at the end of the day, I let her develop something on Arduino platform.
Okay.
Okay. And is it possible for us to work together to in terms of internship, where you provide one of your maybe your student with a very good knowledge on STM32 programming and so on, so that
Okay.
we can so-called develop some kind of IoT project over here.
Okay.
If that is possible, then I think I will get in touch with you later on.
Okay. Okay, Cik Syukur. All right. Okay. With regards to the students' knowledge of the Arduino, again, Arduino is it's very famous and it's very easy to learn, especially for the beginners. So that's why the students are more exposed to Arduino compared to STM32. But then again, from what I've been demoing today, you can have the middle ground, meaning that you have the Arduino coding style, Arduino, not language, Arduino styles of programming, and then the code can be applied towards the STM32 hardware, STM32 ports. So the middle ground will be the STM32 Arduino. Maybe from our cases that the topics or the subjects that focusing on the STM32, it's more like the elective subjects rather than a core program subjects. So that maybe a few those students who not enroll to the subject maybe have less information compared to ones that already gone through the whole semester. So that will be I will look into it, and then and then we can expand or make awareness of the availability of these some of these code compatible.
Assalamualaikum, Dr. Sani.
Waalaikumsalam.
Jamaluddin here.
Yeah, ya.
Okay. I just want to ask about the security aspect because as you know, some company they are very concerned about employee accessing to certain area or for example, you want to go to certain protocol, right? So
Correct.
is there any way that it doesn't go through that area lah? Instead it goes local or some other means lah, instead of going through the security aspect of it.
Yep. Okay. Valid question, Cik Jamal. It's the concerns that most of the companies that I've been approached, it's all concerning the security, the integrity aspect of the IoT system. To the best of my knowledge, it's not my forte about the security parts. The security method or the secure algorithm can be employed either from the device sides or the router sides, meaning that you have all those SSL certificates and so on. You have some sort of encryptions and so on. It can be done. It can be what we call implemented towards various level degree of security. The thing about it is it will hamper performance. Of course, if you have to go through several layers of security, the performance will degrade. So that can be discussed further. But there are ways to do it. But from the get-go, it will be better if you have some sort of isolations for the IoT system, which is the IoT system parts, which is isolated from the backbone of the other types of network. That will be the very simplest part. But then again, when you isolate your network, you're missing a lot of flexibilities in terms of in terms of access, meaning that you must be at the local scene, you must access to the own Wi-Fi router, you cannot access through the internet without some sort of port forwarding and so on. You cannot access your data from remote, for example. There's some sort of what we call difficulties when you're using locals, we're using local network. But that will be the safest thing, isolate island, for example. But if you have to go for the internet, there's some sort of SSL or certificate layers that need to be embed towards the IoT data transfer mostly. It can be done, but for my perspective, a few lectures have been doing this from our team. Dr. Lim, for example, have been what we call researching on this IoT security, data transfer, encryption, and so on. Maybe we can explore more towards later.
Salam doktor.
Alright.
Dengar tak?
Hello, ya.
Dengar.
Okay, okay.
Doktor, I believe UTM also have collaborate with ST for the some IoT project. Am I right?
Yeah, correct.
So how you because the data must get over the net, mostly blocked by our security.
Correct.
Uh, so what is the protocol currently you're using for this project? For the current project you use at ST, the protocol like MQTT and the currently like ThinkSpeak is only collect data, right? It cannot control to the IoT node. Last time we training with you using
Yeah.
Cayenne.
Yeah, correct.
So so now what is the setup you are using in ST?
For the current time, we're using the what we call the Cayenne is still on. And then for the IT platforms, we're still using TeamSpeak, we're using Favorite. This is more towards the data analytics. We're focusing on data analytics themselves in the IoT development, the back end stuff, meaning that all the data being collected, analyzed, and then perform a new types of informations. This is where the ThinkSpeak and favorites are more what we call ahead. But we talk about feedback duplex, meaning data sent and data received. Cayenne it's still what we call the ones that we've been implementing right now. For example, there are a few our lecturers are using for agriculture that are utilizing Cayenne, not the free account, the paid account for agriculture stuff, meaning that for the watering the plants, the fertilization and so on, temperature so on. And also for the Sungai Melaka project, our researchers also using the ThingsWork, again paid versions, to just collect the data and to pull off some sort of notifications. So depends on the application themselves. If the data collected just for the what we call data for the purpose of data analytics, meaning you have to consolidate all the data to produce some sort of new informations, then my preference will be the favorite and also the ThinkSpeak. ThinkSpeak also has some sort of not feedback, more like a tweet, for example, a notification there is this. Okay. And then for favorite also, they are compatible with Node-RED. Node-RED is another platform that are able to send data back towards the nodes itself. So there will be other steps that are required to perform the feedback coming in and going out from the database. So the first data analytics will be those two. Cayenne will be the choice for direct communication from the server from the nodes to server and server back to nodes. Server means database. So, nodes to database and database back to the nodes. Cayenne will be.
How about the network setup? Are you set up MQTT receiver or server inside ST?
No, we haven't done that inside ST. Within my project, we have what we call the isolated the server the using Raspberry Pi. We call it
So it's outside network,
outside
not
network.
ST network. Oh, okay.
Nah, yeah, it's isolated. It's an island.
Mm.
So you have to log into the Wi-Fi of that network, the router, and then you can access all the data. That's it. That's its plan for. But that we're using, I think HTTP. I think, yeah. But MQTT is much faster, but HTTP is more what we call pervasive.
So the board you are using in ST is STM32 or other board?
It's STM32, of course. we're utilizing the F411RE, which is available inside our lab. Yeah, and then we also try to accommodate the IT01A.
So is there any way to reduce the limitation of this gateway? I mean, like let new device that like there is a UWB protocol.
Okay, all right. Yeah.
So is there any current IoT board that can utilize this? So then that's direct to IoT board to this UWB receiver.
Okay. We talk about UWB. Okay. It's back to the it's back to the library availability. Because when the manufacturers, let's say ST, come up with this UWB protocol and so on, it always accompanied with a certain library that is applicable towards the certain boards or certain applications. So in case of new development or new protocols or new what we call algorithm, it's always back to the manufacturer to provide the library themselves. So meaning that for UWB itself, it will be best to utilize the Cube IDE, the ST own Cube IDE, STM32 Cube IDE environment. So the libraries come from their setups. The configuration can be also be set up using the software, using those IDE, and then we can further work on the applications. The same things goes for the Pico, the one I mentioned from the Raspberry Pi. So when Raspberry Pi come up with Pico, Raspberry Pi themselves need to come out with their own libraries so that other developers, such as they're using Arduino or Mbed, for example, have the capability to program the Pico. But the library itself must come from the manufacturers itself, which is in the case of Raspberry Pi. For UWB series will be the STs. I think ST has already provided with the libraries of some sort. So again, the ecosystem is better suited within the manufacturer's scope of development tools. That will be the best case scenario lah. Right?
Okay, thank you, Dr.
Okay.
Right, thank you for the question. So if you have further question, maybe you can contact directly